Welcome to your Math 1 Unit 2 study guide. In this video, we're going to talk about Objective 1. Let's look at question number 1. It says, simplify and write the answer in exponential form. Exponential form is another way to say fractional form. Okay, or rational form. Okay. So when we look at this, we're going to take this and we're going to break each of the variables and each of the numbers down into individual items. Okay? So we'll take the third root of 27, the third root of x, and the third root of y to the third. Okay? And I break this down individually because it's easier to see when you chunk it versus when you try to do it all at one time. Okay, the third root of 27 is asking what to the third power will give us 27, or what times itself 3 times will give us that. So if you go down the list, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 9 times 3, which is 27. So then this all becomes 3. So then that's how you do the numbers. You just want to try to see what will go into it. If by chance nothing would have gone into that, that has an exponent of 1, and then you do to the 1/3 power. Okay, so you take whatever the exponent is, and you divide it by that 3. Okay. When we look at the x, what's the exponent on x? It's a 1. And so this is like the division sign, but for exponent. So it's like your old school divide symbol, but it's telling you, it puts this little shelf bar up here so that you will know that it's for the exponents and not the whole numbers. So this means we're going to divide. And so really you're just going to take this 3 and you're going to put it and divide the exponent. And so you're going to get x to the 1 over 3. And then the same thing's going to happen here. You take this 3 and you're going to divide this 3 for the y, and you get y to the 3 over 3. And then for our final answer, you always want to make sure you write it in simplest form. 3 can't reduce any further. X to the 1/3 will not reduce any further, but 3 over 3 equals 1. And so then you'll get y to the 1, which is the same thing as y. And that's our final answer. Question number 2. This says write your answer in radical form. Okay? So this symbol is called a radical. And so that's the form that you'll write it in. You'll write it using these instead of fractions as exponents. Okay? So if you think back to your perfect squares list, you have 1, 4, 9, 16, 25, 36, 49, 64, and the list keeps going. But we're looking for our perfect squares for this, or see if 54 is a perfect square. And we'll see 54 is not a perfect square if it's between 49 and 64. And since it does that, we can't take the perfect square of 54 and get a simple, nice, neat number. So what we're going to have to do is we're going to have to break it down into 2 numbers that will multiply to give us 54, one of them being a perfect square. And so you look, and the biggest number, always start from the biggest and work your way back, the biggest number that will multiply to 54 is 9. And so we'll break that up into 9 times 6. Okay? And these both stay under the square roots. So all we did was take the square root of 54 and break it up into 9 and 6. Okay? Now the square root of 9 is 3, and then you have the square root of 6 remaining. Okay? So now we're going to take this x to the 4th, and we're going to take the square root of it. So I'm going to pull it off to the side over here. I'm going to take the square root of x to the 4th. Now in the previous question we learned that this is like the divide symbol, okay? And this is the square root. And the reason we say square root is because there's an understood 2 here. So this is like saying 2 and 4 like this. 4 divided by 2. And so we're going to work it out like it's a long division problem. 2 goes into 4 2 times. And then you have a remainder of 0. So what that means is we'll have an x with a 2 on the outside and then a remainder of an x with 0 on the inside, which means we won't have 1 on the inside. We'll have 0 remaining under the radical. Okay? And this will be a little more clear when we do y to the 5th. So we're going to take y to the 5th now, and so you square root of y to the 5th. And remember, there's an understood 2 here, which means that's like 5 divided by 2. And then 2 goes into 5 2 times, sorry, jumping ahead. And that gives us 4 with a remainder of 1. Okay? So then that means that we'll have 2 on the outside with 1 remaining on the inside. Okay? And then we do the same thing for z. So now if you can see, I'll do it over here on this side. So you get square root of z to the 3rd. That's a square. So that means we have 3 divided by 2. 2 goes into 3 one time. You get 2 with a remainder of 1. And so that means we have 1z on the outside and a remainder of 1z on the inside. Okay? So now that doesn't look very simplified, right? So what we're going to do is we're going to clean this up a little bit and put all the stuff that's on the outside together and all the stuff that's on the inside together. So if you look, 3 is on the outside, x squared is on the outside, y squared is on the outside, and z to the 1st is on the outside of the radical. So what we're going to do is we're going to push all these together, and if they have a simplifiable exponent, we'll simplify them. So 3 comes down, x squared will come down, y squared will come down, and then z to the 1st, which can be simplified to just z. Okay? Then we'll look, all the stuff that's under the radical can be put together, and so you'll get square root of 6 y z. Okay? And that'll be our final answer. Simplify and write your answer in exponential form. So remember, that's like fractional exponents, so fractions. Okay? So we look here, we have the 4th root. Okay? So we're going to try to take the 4th root of 81, and then you can use your calculator for this. So in your calculator, you would press the number 4, then you would press math, and then number 5, I think it says 5 colon the little x like this, and that'll let you do the 4th root, so it'll look like this for some calculators. And then you'll actually just type in 81 like this, and that should give you 3, because 3 times 3 times 3 times 3, which is 9 times 9, is 81. Okay, so 4th root of 81 is 3. Since we're writing this in exponential form, this just divides all of the exponents, as we've seen that this is the big exponent division sign. So you'll get x to the 7 over 4, y to the 6 over 4, and z to the 32 over 4. And then we just want to simplify and clean this up. 3 won't simplify any further. 7 over 4 will not simplify any further. 6 over 4 actually can be divided by 2, or reduced by 2. And so you get y to the 3 over 2. And then you get z. 32 divided by 4 is 8. So that becomes our final answer. So we'll simplify and write the expression in radical form. So that's very similar to one we did in question number 2. except they give us a fraction exponent. Okay? So there's two ways you can approach it. So I'll tackle it in two ways. The first way is you can go ahead and instantly put this in radical form and then simplify it. And then the other way is you can distribute it and then turn that into radical form from there. Okay? So the first way is this is to the 1/3 power. Notice how you're dividing by 3. And if we look back at the previous question, when you're dividing by 4, that really means you had a 4 on the outside of the radical. So we'll look at this. This really means we could put 3 on the outside of the radical. So I'm going to do that here. I'm going to rewrite this using the radical 8x squared y to the 6th z to the 3rd. Okay? And that's what that 1/3 power really means. Okay? So now that I have it like this, I just do what I did before. What's the 3rd root of 8? So you take the 3rd root of 8, that's 2. So I get this down to 2. Now we do the 3rd root of x squared. Well, that's the same thing as 2 divided by 3. 3 will go into 2 0 times. So put 0. So you'll have 0 x's on the outside and 2 remaining on the inside. So I'll do the 3rd root with 2 x's remaining on the outside. And notice how there wasn't enough 2's to make up for that 3. Like you couldn't take any 3's out of the 2. It's not big enough. That's why it stays in there. Can't do anything with it. So then we look at this y to the 6th. And we do the 3rd root. Well, that really means 6 divided by 3. 3 goes into 6 2 times, and you get 6 with a remainder of 0. Okay? So that means this 2 will come outside. You'll have y to the 2nd on the outside. Okay? And then there's 0 left under the radical. Alright? And then we'll look at z. So you have the 3rd root of z to the 3rd. Okay? Well, that's really like 3 divided by 3. 3 goes into 3 one time, and you get 3 with a remainder of 0. So that means you have 1 on the outside and 0 on the inside. Okay? So simplify this out. The 2 will come down because it's on the outside. The y is on the outside, so it'll come down. And the z is on the outside. And then we're going to just take away the 1 power and leave it as z. And then the only thing that's left under the radical is the x squared. Don't forget about your index here, the number 3. You must have that for your answer. Okay? So that's way number 1. If you've got it from there, you can stop the video, and then you can move on to objective 2. The second way you could do it is you can distribute the 1/3 to all of the exponents inside there. This says 8 to the 1/3, so you write 8 to the 1/3. This says x to the 2 times 1/3, y to the 6 times 1/3, and z to the 3 times 1/3. Okay? Or you could have done 1 times 1/3. Doesn't matter. Okay? So now the 1/3 power we learned earlier is the same thing as the 3rd root of 8. But you can still type it in the calculator as the 8 to the 1/3 power. And either way you'll get 2. Okay? So now this gives us x to the 2/3 power. This gives us y to the 2nd. And this gives us z to the 1. Okay? So now, it says we need to remember, we got to write our answer in radical form. Well, 8 simplified down to 2, y simplified to y squared, z simplified to z. Okay, the only one that has a fraction, which we can't write it in fraction form if it says radical form, is x. So that's the only one that still has that divide by 3 in there that makes it not work. And so that divide by 3, if you remember, is when we turn it into a radical, like in the previous question, you divide it by 4, well that meant we had a 4 on the outside of the radical. We take that 3 and we'll put it on the outside of the radical. Let's do it in purple. So we'll take that 3, put it on the outside of the radical, and write what's left. And so then that gives us our final answer, and if you'll look, it's the same answer. Thank you for watching the Objective 1 study guide video for Unit 2. Please move on to the next video.